where we're calculating the normal distribution. So for the normal distribution, continuous variables, if it's x is less than or equal to a value and x is less than a value, they mean the same thing, but this is not the case for discrete variables. So if you start with an example, the height of individuals in a city could be modelled by normal distribution with a mean 160 and a standard deviation of 15. Calculate the probability that a random selected individual is less than 120 centimeters tall and is between 130 centimeters and 150 centimeters tall. So we've got the calculator, menu, one distribution, and then we want to go on normal CD. And then for this one, so we want the probability that someone is less than 120 centimeters tall. So for the lower, we do 0, upper 120, standard deviation is 15 given in the question, and the mean is 160 given in the question. So our probability is 3.83 times 10 to the negative 3. So for our next one, is between 130 and 150 centimeters. So we have 130 and 150. So our probability is 0.23. The next one, the masses of oranges are normally distributed with a mean mass of 150. So, and standard deviation of 25. The oranges are classed as medium if they are between 130 and 175. So we want to find the probability that an apple is medium. So 135, 175, standard deviation is 25, and the mean is 150. That means 0.567. So we could say 56.7% are medium. So the next one, the time to climb a set of stairs by a group of children can be modelled by normal distribution. The mean time is 60 seconds and the standard deviation is 3 seconds. Find the probability that a randomly chosen child will climb the stairs under 55 seconds. So normal, 0, 55, standard deviation 3, and mean 60. So the probability is 0.048. Do some more. So now if we look at the inverse normal distribution, so for a given probability p, the inverse normal distribution gives the value of x, where the probability of x less than x is p. So for an example, IQ tests were designed to have a mean of 100 and a standard deviation of 15. What is the IQ score needed to be in the top 2%? So we want the probability that x is less than or equal to some value that we don't know. So x equals 0.02. Now, what IQ score is needed to be in the top 2%? So the top 2 means on the right hand side. So if we look at the normal distribution, we want the top 2, so this side. So if we find this value of x and we find the probability below it, we do 1 minus that to get this value. So if we rearrange, we have 0.98 equals probability that x is less than this value. So if we go on distribution, inverse normal, so the area is 0.98 and we have a standard deviation of 15 and a mean of 100. Then our value of x is 130.8. So you need to get a score of 130.8 or higher to be in the top 2%. Further example, the amount of water dispensed by a machine follows a normal distribution with a mean of 150 and a variance. So variance is standard deviation squared. So the standard deviation is 6. Calculate the probability that the machine dispenses less than 125 milliliters. So we want x is less than or equal to 125. So if we do that, we want normal. So lower is 0, upper is 125. The standard deviation is 6 and the mean is 150. The probability is 1.55 times 10 to the negative 5. So next one, the value of k. So we need to calculate the value of k if 15% of the cups contain more than k ml of water. So if we draw the normal distribution, so we have this value of k and 15% of the cups contain more than this value. So this is 0.15, right? And this 0.85. So we need to find this value of k. So the probability that x is less than or equal to k is 0.85. So if we go on distribution, inverse, the area is 0.85, standard deviation is 6, and the mean is 150. Our value of k is 156.2 milliliters. So for the next example, times taken for runners to complete a 5k run are normally distributed with a mean of 32 minutes and a variance of 25 or a standard deviation of 5. Calculate the probability that a runner completes the run in less than 25 minutes. So we want the probability that x is less than or equal to 25 minutes. So we have normal CD, lower is 0, upper is 25, standard deviation is 5, and the mean is 32. So the probability equals 0.08. The value of A, where 90% of the runners complete the run in less than A minutes. So we have a random value A, where 90% of the runners complete the run within this. So this is 0.9 and this is 0.1. So we have the probability that x is less than or equal to A equals 9. 0.9, because it's 90%. So if we're on distribution, inverse, the area is 0.9 and the standard deviation is 5, mean 32. We had a value of A as 38.4. So in 38.4 minutes, 90% of the runners have completed the race. And that's it.